Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to review how to solve linear equations with two variables. So specifically, we are going to talk about graphing. Now this kind of math comes up often when you do lab work and you're dealing with calibration curves. So let's jump in. Okay, so we are ready to start solving linear equations with two variables in this video. Before we jump into the calculations, I want to talk about a couple of things. So first, let's talk about the slope of the line. This is the change in y over the change in x, sometimes called rise over run. Now, slopes can be positive or negative. If you see this blue line here, this is a positive slope. It is increasing as the x value is increasing. This gray line here is a negative slope. You can see it's decreasing as x is increasing. So a lot of times students feel like slopes must always be positive. That is not necessarily true. Slopes can also be negative. Let's talk a little bit about our intercepts. So we have a y-intercept on the graph. This is where your line is going to cross the y-axis. So you can see on this blue line here, it actually intercepts the origin, but it crosses the y-axis at 0. However, your y-intercept for this gray line is crossing up here at about 7. Our orange line here, we would have to extrapolate out. It looks like it would cross maybe a little bit below the origin. And depending on what application you're doing, you may or may not have to extrapolate this kind of line to the y-axis, or you might have to do it to the x-axis. So let's talk about the x-intercept. This occurs when the value for y equals 0, and it's where your line is going to cross the x-axis. Again, for this blue line, because it intercepts at the origin, it crosses both the x-axis and the y-axis at 0, 0. Your gray line here, of course, though, is crossing the x-axis at about 2.5. Again, for your orange line, if you wanted to know where it crossed the x-axis, you would have to extrapolate this out. Again, it looks like it's close to the origin, but maybe a little bit on the positive side. Okay, let's actually look at some numbers. So the first thing I want to practice is just finding the slope between 2 points. Now remember, your slope is your change in y over your change in x. You can always write this as y2 minus y1 over x2 minus x1. So as we're looking at our 2 points right here, or our ordered pairs, we're simply going to find the difference between the y values and the difference between the x values. So let's go ahead and do that. So our slope is going to be our y2, which is 5, minus our y1, which is 8, over our x2, which is 1, minus 3, which is our x1. And this gives us a slope of 3/2. Now I set this ordered pair to be x1, y1, and x2, y2. But you don't necessarily have to do it that way. You can always flip-flop your pairs. So for this example over here, when I calculate slope, I'm going to consider this first ordered pair, x2, y2, and then x1, y1. This is going to give me a slope of negative 7.9 minus negative 11.2 over 1.5 minus negative 4.6. This gives me a slope of 3.3 over 6.1, which equals 0.54. The most important thing is that you keep your x's and your y's straight. So you'll notice in my calculation, my negative 7.9 is right above my 1.5. So the most common mistake that I see is students might start with this y value to subtract, and then they go to the x value in the other ordered pair. So just make sure you're really clear on what your x1 and your x2 is and your y1 and your y2 are, and then you will get the correct slope. Okay, but slope is just the first part, because really when we've got a graph, we want the equation of the line. And when we talk about the equation of the line, we're most often talking about slope-intercept form. So your m here, of course, is slope, like we've already calculated, and your b is your y-intercept. So how do we get the slope-intercept form when we're given 2 points? Well, I find the easiest thing to do is to first simply calculate slope, like we have done before, and then use the point slope form where you're going to plug in values for y1 and x1 to then get the slope intercept form. So let me show you how I do that. I'm going to take these 2 points and I'm going to get the slope-intercept form. I'm just going to rewrite my points over here. 7, 1. First, I'm going to calculate slope. So this is 1 minus 5 over 7 minus 2, which gives me a slope of negative 4 over 5. Now that I have my slope, I'm going to use my point slope form to get my equation for the line. So that is going to be y minus y1 is equal to m times x minus x1. I can use either point here to plug into my point slope form. It does not matter which one. I will go ahead and use my first point. So that is going to give me y minus 5 is equal to my slope, which I just calculated, times x minus 2. So all I need to do now is a little bit of algebra, combine like terms, and I will get my slope-intercept form. So the left-hand side of my equation stays the same. I'm going to distribute here, plus 8 over 5. Now combine like terms, which basically means I'm going to take my constant to the right-hand side, and that gives me y equals negative 4/5 x plus 33 over 5, or if you prefer decimals, this is y equals negative 0.8 x plus 6.6. Both of these equations are valid for the slope-intercept form. Let's do the same thing, but with another ordered pair. Again, the first thing that I want to do is I want to calculate slope. Let me rewrite my ordered pair right here. Of course, slope is just change in y over change in x. Now, when you're doing this, just make sure you're watching your negatives. So this gives me a slope of negative 4.6. Now, using my point slope form, let's use this point this time for my point slope form. That's going to give me y minus negative 23. Is equal to my slope, which is negative 4.6, times x minus negative 7. When you have a lot of negatives, as in this problem right here, it does help to use a lot of parentheses. Just keep yourself organized so that you know whether you're subtracting or adding. Okay, so this is going to give me y plus 23 is equal to negative 4.6x minus 32.2. Combining like terms, I'm going to get y equals negative 4.6x minus 55.2. Now, there is one more thing that I want to do with graphing. Very often you will be given the slope-intercept form for a line, but you want to find either an x or a y value at a certain point. So this is very common if you have a calibration curve and then you have an unknown. So let's do a couple of these types of problems. So for our first one, you can see we are given the equation of the line, and then we're given a value for y. So what we want to do is we want to solve for the value of x that is true at this value of y. So starting with the equation of the line that I have been given, I am simply going to plug in my value of y. So that is 5.67. 3.15x plus 1.79. So all I need to do is algebraically solve for x. This becomes 3.88 equals 3.15x, and so therefore x equals 1.23. Let's do this one more time with my second example. Again, we're given the equation of the line. This time we are given a value for x, and we want to solve for the value for y. So starting with my equation for the line, x minus 0.0912. I'm going to plug in my value for x. So everything else stays the same, except now I have a value for x. 912. Okay, so now I'm just putting in my calculator and getting a value out for y, which is 0.0416. Again, this is very common when you've got a calibration curve and then you have an unknown. You'll get an equation for a line, and then you've got to figure out what's going on with your unknown. I hope this video helped refresh all of those linear graphing skills. Again, this is most often found in lab work. However, don't be fooled. These kind of questions do often show up on tests and exams. Now, if you need review on other math topics, you can check out these videos here, and thanks so much for watching.